Hello, I am recording this video to go over another question in the calculus end of topic test, which I also found a bit difficult to comprehensively understand. I suppose you could say that this video is for people who may be afraid to ask for help with maths. I'm not sure why, but you should definitely ask help for maths. Otherwise you're just going to be really crap at it for a longer time. And I wouldn't try studying it all at once before you've got a test or an exam. I've done it a few times and I have gotten okay grades, but you've got to already have a decent understanding of maths to be able to do that kind of thing. And if you don't already, then yes, well, maybe this video is for you. Okay, I'll go over the question now. Enough red tape nonsense. Right, okay, so question 1c. For what values of x is the curve y equals 3 take away 5x plus 3x squared take away a third x cubed? Okay, so right, this is calculus. So with this question we're going to want the derivative of y with respect to x, which is written as like this, to be greater than 0, which should give us d divided by dx y, which equals dy by dx, not dy, d divided by dx 3 take away 5x plus 3x squared take away a third x cubed. Cool. Which implies that dy divided by dx d equals negative x squared plus 6x take away 5 must be greater than 0. I might need to double check that there doesn't. Yes. That's fine. So I've differentiated this expression here, this equation, this function, and I've made it look like this nice an equation here, which should be quite easy to solve using lovely level 1 maths knowledge, which we should all know. Okay, so now we're going to be doing some lovely factorizing, because we've got a nice an equation here, but we want to solve it. So we're going to do right. So if we factorize this expression, which is very easy, I'm just going to do it by hand since it's really easy. Negative x take away 5 x take away 1 must be greater than 0, therefore x must be greater than 1, or x must be less than 5. Or we could write it like this, this is a nice way to write it. It makes things a lot easier. Yes. Cool. Yep, that's good. I'm going to have a nice shot of that. As you can see, this is very comprehensive. Oh, this is a lot easier than the other question. And then all we have to do now is, well, I assume we could, well, I haven't really explained it, I've just done it. So what the question's asking for is it wants values of x where the curve is increasing. And from what we can tell, when we differentiated this, we ended up with a quadratic, which represents the graph, which is a parabola. So if we drew that really quickly, let's make a nice Y and X. I should have done the X first, but who cares? How nice, lovely X and Y plane. Oh, bran biscuit. Oh, speaking of bran biscuits, I've been eating these lovely bran biscuits, and they're really good. I got recommended to them by a person that works at McGregor's, one of my colleagues, former colleagues, and they were like, they had them on like this. I just tried them for free, and then I decided to buy a packet. That's the idea, and they're really good. Yum, all that, delicious. Anyway, so probably going to be over here somewhere. This is what it's going to look. Oh, it's a lovely parabola. Whoa, so good at drawing that. So we know that this area here, this part of the graph is positive. 1, 2, 3, 4, 5. That part of the x-axis is positive. 1, 2, 3, 4, 5, and so on. And then that one's negative, and that's negative. So what we're looking for is, I want to use a highlighter now. I'm going to be fancy. Is we're looking for where the graph is greater than 0, which is here. That's what we've just found. And we've found values of x, which this is true. So, with a question like this, you could actually prove it. You can justify it. I'm not sure if the question calls for you to justify it. I mean, this is basically what I've done here is adequate justification, but sometimes questions will say justify fully, or yeah, something like that. Justify it, provide justification, or something like that. So if you're going to do that with a question like this, the way I would do it is I'd find a value of x, which is like this. So okay, well, let's make x equals 2. Cool. This is hypothetically speaking, x equals 2. That means that the derivative of y with respect to x would be equal 3, which is greater than 0, which means that the graph is actually increasing. So therefore, the graph is increasing. Yeah, so that's correct. That's good. I could have done other values of x, but I'm being a bit lazy with this question because it's a bit of a. Oh, I think this is an excellence question, honestly. No, it definitely is an excellence question. I only ever get stuck on excellence questions. I'm not a merit student. I'm an excellence student in calculus. Oh, I sound really cocky. Anyway, that's questions done. You have a nice look at that. If it's even any help to you. Well, let's flip the camera. Oh, good. It's working. Okay, so that's that question for tonight. Yeah, I think it was a good question. I liked it. I thought it might help people, because I know there's probably no point in me helping people who are already good at maths, like, I don't know, George or Sam or Alex or anybody like that. And speaking of George, what the hell? Hold on. I just need to, hopefully my phone doesn't fall. George Yank says what? Sorry. What does George Yank say? What's he saying? I want to see. I can only tell him through Hangout, so I won't be much help. Oh, never mind. That conversation does not involve me. Sorry, George Yank. George, I will not be responding to you on Hangouts because you're talking to somebody else. Anyway, yep. So these bran biscuits are really good. I really like them. I'll be wow. Cool. I would have cracked it a 3 or 5 for I expected them to be like really crap, because like graham crackers or something. That's so nice. Yeah. Anyway, thank you very much for watching. If you did watch this whole video. Goodbye.